Types of vaccines. In this session, we are going to look at whole organism vaccines. Let us look at the learning outcomes of the session. Whole organism vaccines are either inactivated microbes, so it can be inactivated bacteria or inactivated virus, or they can be weakened or attenuated pathogens, with the objective being that because they are whole, the antigenicity or the immunogenicity is maintained. The whole organism vaccine aims to drive the activation of humoral or cell mediated immunity or both, and developing immunologic memory. Methodologies have been standardized to inactivate and attenuate pathogens, which can also decide the dose and the route of administration of these vaccines. There are advantages and disadvantages associated with both the type of vaccines. So let's begin with a table. This table has been taken from immunology by the text of immunology by Kubi. And you can see over here very well that for several bacterial cells, be it anthrax, cholera, pertussis, plague, hepatitis A, influenza, polio, Salk, the Salk variants of polio, rabies, all of them are inactivated whole organisms. But at the same time, you can see that there is live attenuated whole organism vaccines as well, say as in for tuberculosis or for typhoid, for measles, for mumps, for polio, the Sabin's vaccine is also a live attenuated vaccine. So the understanding therefore is that there are two types of whole organism vaccines. One is the inactive whole organism vaccine, and second is the live attenuated whole organism vaccines. So let us first look at inactivated whole organisms. Now, what is generally done is that these pathogens are grown in vitro so that a large number of the pathogens are formed. And because one is dealing with pathogens, one has to ensure that while they are culturing it in a high level of biosafety cabinets. Secondly, once the pathogens are grown and the pathogens are isolated, they are subjected to either heat treatment or they are treated with a chemical. The purpose is to inactivate the pathogen. And by inactivation, there are two things that are addressed. One, that on inactivation, the pathogens are rendered incapable of multiplying, or basically they are not able to replicate inside the host per se. And so therefore when it is injected into a recipient, the dose that is given, that dose is the amount of the inactivated virus that is going to, or inactivated bacteria that is going to be given to the person. Now, secondly, the process of inactivation should be such that it should not change the structures of the antigenic determinants which are present on the surface of the bacteria or surface of the virus. So that has to be taken care of. Otherwise, the antigenicity or the immunogenicity is going to be lost. So now, when one talks about inactivation and tries to address the fact that the structures of the epitopes should not change, then what has been observed is that heat inactivation may lead to denaturation of certain surface proteins. But what has been observed that treatment with formaldehyde or with certain halides have been more successful in maintaining the conformation of these epitopes. So therefore, most vaccines have preferred to use chemical treatment over heat treatment. Now, Jonas Salk, okay, as you can see in the Time magazine, he was on the front page because of his discovery of the polio vaccine. This is kind of telling you that his contribution to bring out a vaccine for polio is just immeasurable. You cannot think of how important a contribution this has been. So he showed the efficacy of the vaccine that he made for polio in 1955. And what he used is, of course, inactivated poliovirus. So his formulation comprised a suspension of three poliovirus strains, that is PV1, PV2, and PV3. And it was found that the IPV, that is the inactivated polio version, was therefore effective against all the three strains of poliovirus. So you can understand that with one vaccine you are taking care of three strains of the poliovirus. All these three strains were inactivated using formaldehyde, and the vaccine was administered as an intramuscular injection. So it was observed that it could elicit a very strong humoral response and could also develop an immunologic memory. Now, booster doses are recommended for the inactivated poliovirus. When you say booster dose, what does it mean? It means that you may need more than one dose of the vaccine to be given in order to create or in order to develop a good immunological memory. If one needs a long time protection or a lifelong protection from polio, then booster doses in case of inactivated poliovirus are needed. And the first dose itself is given as early as 2 month old children. Now, being inactive, so because we have inactivated all the three strains, therefore, uh, these inactivated viruses, once they are present in circulation, the host system's antibodies will bind to it, form a complex, immune complex, and those immune complexes are eliminated either through complement pathway or through phagocytosis or things like that. So basically, what we are trying to understand is that because it is inactive, its presence in the host is not for a very long period. It is the duration of exposure of the host to that particular antigen or to these antigens are less, and hence you need multiple doses, because in one dose uh, enough of immune response may not have been generated before the immunological memory is formed. It is possible that the body has already eliminated these inactive viruses. So in order to ensure that an immunologic memory is developed, a second dose is to be given. On giving the second dose, you would have further enhancement of immunologic memory, and by the third or the fourth dose, you will find that you have a very strong immunologic memory being formed, and because of that, you can have lifelong protection. There is another thing that is related to inactivated poliovirus, and that is, although it can elicit a strong humoral response, it is not able to elicit a cell-mediated response and not even a secretory response. That is, mucosal immunity is also not developed, which means secretory IgA is not an antibody that is formed when one uses inactivated polio viruses. Um, so this is something, but what is important to note is that the moment he was able to come out with the vaccine, and when the vaccines were being administered to people, the cases of polio, the cases of people suffering from polio decreased to a lot of extent, and today at this stage polio is considered to be one of the diseases that can be considered to be eradicated in a few more years. Now, of course, there is a risk associated with the inactivated poliovirus, and that is, if the inactivation has not been done properly, then obviously the polioviruses can become active, and when they become active, they can cause paralytic damage. So this risk is definitely there. The second risk also could be that because these are inactivated polioviruses, sometimes you would have batches which do not work at all. That is also possible. Now, attenuation or attenuated whole organisms are the second type of whole organism vaccines. And the purpose of attenuation is two. One, that any attenuation should lead to no pathogenicity, which means that the bacteria or the virus should become completely avirulent. Okay. So they should have no longer any virulence associated. So when injected into the subject does not uh, undergo an infection, does not have symptoms related to the disease per se. The second is attenuation should lead to a transient growth potential. That means it should not stop the multiplication of the whole organism. That means it should be able to replicate or multiply, maybe at a much slower rate than the virulent form is, but yet because it can grow inside the host, there are two advantages. Okay, now before we go into the advantages, let us understand, or let us try to ask the question, how can an attenuated state be attained? How do you make a whole organism attenuated? So one of the ways is by growing the pathogens in abnormal conditions. So we could call it also as stressed conditions. So you grow it in stressed conditions for extended periods, and that leads to the pathogen adapting to the stressed condition, by lieu of which what can happen is that the pathogen learns to survive, but in the process it has stopped becoming virulent. So this is one way, which means that under stressed conditions, the pathogen is going to become more and more weak. This is what Louis Pasteur had observed, and he was the one who had actually developed attenuated live vaccines. Example of this is BCG. This stands for Bacillus calmette-guerin. So Bacillus calmette-guerin is the vaccine that is used for tuberculosis, and this has been developed by growing Mycobacterium bovis in high bile containing media. So bile is not a favorable component for the growth of the mycobacterium, but when you're introducing a high bile content in the media, then you're basically subjecting the mycobacterium bovis to stress or to an abnormal condition. And so what was observed is it took about 13 years of culturing the mycobacterium bovis in bile containing media to actually make it attenuated. And only after 13 years, once they were ensured that it is attenuated enough, they were able to use this as a vaccine. So although it seems an easy process, it is easier said than done. The second method is to grow the pathogens in cell lines that are not their natural cell lines. That is, they are cell lines different from the natural host cells. So for example, Sabin's oral poliovirus. Now for polio, generally the natural hosts are human beings. But suppose you grow the viruses in monkey kidney epithelial cells, then monkey kidney epithelial cells are not the natural host cells. So therefore, the viruses will have to adapt to grow in the monkey kidney epithelial cells. And in the process of adaptation, because of internal mutations, what can happen is that the viruses can become weak, or they can become less virulent, or they can become completely virulent, avirulent. And then these viruses can be used as a vaccine, because now when they are injected in a human subject, then they will not be able to cause the disease, but the antigenicity is there, the immunogenicity is there because it is still live. Another example is that of measles vaccine. So the pathogen was grown in duck embryo cells, and then having grown it in duck embryo cells for several generations, it was then transferred into human cells. So now when it was in the human cells, it was observed that it wasn't virulent. So it has lost its virulence, but it has not lost its immunogenicity, and that is what is important. With live attenuated, that is something that is extremely important. That is, it loses its pathogenicity but not its immunogenicity. That means all the surface epitopes are present, and that can elicit a immune response. Secondly, because it is growing, the number of these cultures or the number of these bacteria or viruses can be present in the body for a longer period of time. So that is important for developing immunologic memory. The third way is by genetic engineering. So most of it has been done by in vitro mutagenesis. So for example, one can delete the genes that are necessary for pathogenesis. So if those genes that are responsible for pathogenesis are completely removed, then of course you will have the whole organism completely avirulent. Now, for example, deleting thymidine kinase for a herpes virus vaccine. Okay, so that makes the herpes virus, which is live, but it is attenuated because now it cannot have any longer pathogenesis, and that is thanks to just deleting thymidine kinase. So these are different ways or approaches by which you can attenuate the whole organisms. Now, what are the advantages of using attenuated whole organisms? Something that we'd already kind of looked at. One, it has the ability to multiply. Because it can multiply, the present in the host body will be for a longer duration of time. So the body or the host is going to be exposed to that antigen for a longer period of time, and that would elicit not just a strong immune response, so it has increased immunogenicity, and the duration is long enough to develop immunologic memory, and both of these are responsible for giving lifelong protection. Another important fact is that because it is present in the body for a longer period of time, a single dose can be enough to give a lifelong protection. So, for many live attenuated whole organism vaccines, a single dose has been prescribed. One doesn't need to go in for more than one dose for many of the live attenuated whole organisms. So, that is definitely an advantage. Now, let us look at the disadvantages. So, of the disadvantages, one of the major risks is that because you're using live attenuated organisms, they may revert back to a stage where they are virulent. And if that happens, then instead of just immunizing, it is actually infecting and giving rise to all the pathological symptoms. And that can become a batch of vaccines which is proving to be fatal rather than proving to be protective. So that is something that has been observed, in fact, in many of the not many, but a few batches of oral poliovirus uh, did become revert back to its virulent form, and it did cause a damage in a small population. But it was immediately removed from the place. It was immediately stopped, and then a new batch was sent. So it is possible with a few batches. That risk is there. Now, another disadvantage is that there may not be a risk of complete, disease. You may need not have the person suffering from the disease, but you could have certain complications associated with the natural disease as part of the vaccine. So, for example, post vaccination of measles vaccine, there were some people that were found to develop encephalitis. Now, you must understand that these cases are rare, but and also important to notice that if you do not use the vaccines, then the damage that the measles would cause would be much larger than if you just have a few such cases which are rare, where you are taking into consideration the fact that majority of the population is being immunized. So this is something there, but it is definitely still a disadvantage. Now, since we talked about Salk's inactivated poliovirus, let us also look at the oral poliovirus, which is having live attenuated viruses. So that was developed by Sabin, and he developed it in around just about the same time as Salk developed his inactivated poliovirus, but probably a year later. And of course, when Stabin studied the poliovirus, he very interestingly noted that the polioviruses first invade the digestive tract and then they go to the nervous system. So he identified, and he was the one who identified the three poliovirus strains, and he attenuated all of the three to formulate the vaccine. And the attenuation was done by using formaldehyde. So what was an advantage of Sabin's oral polio vaccine was that it could be given orally. Okay, so it was an easy administration for children because injections are something which is difficult to give to children, but if it is oral, it becomes much easier. Also, because you have the viruses attenuated, so they remain in the body for a longer period of time, And because they remain in the body for a longer period of time, there are more chances of developing a very strong immunologic memory. So that was one advantage that Sabin's oral polio vaccine had over Sal's inactive polio vaccine. But unlike most live attenuated whole organisms, for oral polio vaccine, booster doses were needed. And what is the question that comes up is then why do we need a booster dose if these are attenuated and they are multiplying in the cell, in the system? So what was observed is that in the first dose, immunization against one particular poliovirus was obtained. In the second dose, it was against the second one, and in the third dose, it was against the third one. So effectively, the body is able to get itself immunized for one strain at a time. This is what was observed, and therefore 3 doses or 4 doses were prescribed for the oral polio vaccine. In many countries, both the OPV, that is the oral polio vaccine, and the inactive poliovirus are administered. So the first 2 or 3 doses are of oral poliovirus, while the last dose, along with the oral poliovirus, even the inactive poliovirus is given. Especially after genetic engineering, the oral poliovirus was from a three strain poliovirus. It was converted to a 2 strain poliovirus, and this 2 strain poliovirus was immunizing against PV1, that is poliovirus 1 and poliovirus 3, and not poliovirus 2. The reason for doing that was to decrease the risk of infection by using these vaccines, because it was observed that the poliovirus 2 was more capable of carrying out or leading to, so the virulence of the uh, poliovirus 2 was greater. So therefore in such a case, and over a period of time, what was also observed is that the poliovirus 2 was gradually diminishing from the population. So it had almost got eradicated. So what remains is the poliovirus 1 and poliovirus 3, and therefore OPV has been modified to address these 2 poliovirus strains now. The inclusion of inactivated poliovirus would still have the poliovirus 2, and that can generate immunization against the poliovirus 2 as well. So let us make the conclusions. Whole organism vaccines help maintaining the immunogenicity as the structural components are not denatured. Whole organisms can be inactivated either by heat treatment or using chemicals. These are able to maintain the antigenicity, but the booster doses may be needed to develop enough memory. Pathogens can be attenuated by growing them in conditions that are stressed or abnormal to enable them to adapt and in the process lose virulence. Mutagenesis is also an approach that is being used now. Live attenuated vaccines have the advantage of strong immunogenicity as well as developing a good immunological memory, even in a single dose. That is something that is very important. So, numerous vaccines have been developed using whole organisms, with these organisms playing a role in eradication of with these vaccines playing a role in eradication of several diseases. Say, for example, smallpox is completely eradicated. Now, tilting the balance towards advantages of these vaccines has been a calculated risk, probably, but it has worked. Thank you.